Well, welcome to lesson 7.5 on proportions in triangles. And we have a couple of theorems that we'll be talking about in this lesson. One of them is called the side splitter theorem, and the other one is called the triangle angle bisector theorem. And our focus question is, what does the side splitter theorem help us to do? So we're going to go ahead and answer that question by starting off just looking at what the theorem says, and then we'll solve some problems using the theorem. So here we go. Theorem 7.4, the side splitter theorem, says this. If we have two lines, RS and XY, and they are parallel to each other, then the sides that they split are proportional. So over here on the right-hand side, if we set up a proportion, the distance from X to R and R to Q is in the same ratio as the distance from Y to S and S to Q. So here's a corollary to that theorem. If we have more than two lines that are parallel and they are cut by two transversals, then all of those sides are proportional. So the ratio of A to B and B to C is the same as W to X and X to Y. So here's an example problem where we would actually use this theorem, and we have a campsite set up here, and we want to know what the distance is. What is this length for the campsite A along the river? And so we're going to go ahead and use the corollary to the side splitter theorem, and so we can go ahead and set up a proportion using that theorem. And here's a proportion. We can say that the side X, we're going to call that X right here, is to 8 as 9 is to 7.2. Okay? Now we could just have easily used the sides for site C, but we don't have the length that we need here. Okay, so if we were given the length of site C, we could have easily chosen that one as well. But since we don't have that, that's why we chose site B's dimensions, because we have both dimensions. So cross multiplying, we get 7.2x equals 72, or x is equal to 10. So what's the importance of the triangle angle bisector theorem? How does that help us to solve problems? Well, the triangle angle bisector theorem says that if we have ray AD and it's an angle bisector, it bisects angle CAB into two equal angles up here. Angle A is split in half equally. Then side CD down here, CD is to DB as AC is to AB. So the ratio of the side that's split is in the same proportion as the lengths of the sides of the triangle. So that one's pretty useful. So let's take a look at how we would use that to solve this problem. What is the value of x in the diagram below? Well, since we have both lengths of this hypotenuse of the triangle, we can go ahead and use the triangle angle bisector theorem. Since this is bisecting the angle, we have PQ is an angle bisector. So to set up that proportion, what we need to do is just say, we could say that RQ is to QS as RP is to PS. And then substituting in the values that we know from the diagram, RQ is 10 and QS is 18. And then PR is 12, and PS is our unknown that we're looking for. And then we know how to solve proportions by cross multiplying, giving us a value of x equal to 21.6. All right, here's one for you to try. Pause the video and see if you can set up the proportion on your own. And I will give you the solution to this one when you get back. All right, hope you gave that a try. So this one should look like this. We're going to say the lengths of the sides, 9.6 is to 16, as y is to 24. And then cross multiplying, we get 16y is equal to 230.4. And then solving for y by dividing by 16, we get y equals 14.4. Here is your lesson check. Go ahead and make sure that you do all 5 of these problems, and we will talk about these when you get to class tomorrow. See you next time.